Today we want to solve a problem on elastic collisions in 2 dimensions. It's 2D. And here's the question. A particle of mass m traveling at a speed v strikes a stationary body of mass 2m. As a result of the particle mass m is deflected through a 45 degrees angle and had its final speed v over 2 meters per second. Find the direction of the particle of the mass 2m after the collision. And here is a sketch. This is a particle mass m traveling with v, and this is a stationary body 2m, and after the collision there's a deflection of 45 degrees angle. So we're asked to find the direction. So using the principles of conservation of momentum, we have that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. But since we are dealing with a stationary body, the u2 is 0 and the whole of this will turn to 0. So we now have m1 u1 equal to m1 v1 plus m2 v2. So normally this has two components, the x component and the y component. So for the x components, we have m1 u1 cos 0, or this, there's no angle here, equal to m1 v1 cos theta plus m2 v2 cos theta. So let's now list out the parameters. For this we have m, because our m1 is m, v cos 0 equal to m1 is m, v1 is v over 2 cos 45 degrees plus m2 is 2m, v2 cos theta. So we know that cos 0 is 1, so this becomes mv equal to mv over 2 cos 45 is 1 over root 2 special angles plus 2m v2 cos theta. Of course, that is the angle we are looking for. So when you look at this, we have m that is common. So we can say that mv is equal to m into v over 2, 1 all over root 2, plus 2v2 cos theta. Of course, this m will take care of this. I will have v to be equal to v over 2, 1 over root 2, plus v 2v2 cos theta. So looking at this, we need to rationalize this. This is solved. So We can now say that V is equal to V over 2, 1 all over root 2 times root 2 all over root 2. That is rationalization. Plus 2V2 cos theta. So by the time you multiply this out, you have V to be equal to V root 2. Root 2 times root 2 is 2 times this. This is 4. Plus 2V2 cos theta. So we need to take this to the other side. So this becomes V minus V root 2 all over 4 plus 2V2 cos theta. So what do? We take the LCM. And what is the LCM? 4. Listen to this 1. So we have V root 2. Listen to this is 4. So we have 4V minus plus 2V2 cos theta. So looking at this, we now have, of course, we know that V is common. So we can write this in the form V into 4 minus root 2 all over 4. You open the brackets, we have this. So remember, this is equal to, it will be equal to 2V2 cos theta. So we can write this as equation 1. So considering the y components, remember for this we have 0 equal to mv all over 2 sine 45 minus, why is it minus? Resolving that on the y component. Remember, we have something like this. So resolving this on the y component, that is the reason why it's minus. So minus, I have mv over 2 sine 45 minus 2m v2 sine theta. So remember, if you divide this equation through by m, we have 0 equal to v over 2 sine 45 minus 2v2 sine theta divided through by m. And by the time you take this to the other side, to the left hand side, it becomes positive. And we can write this equation as v over 2 sine 45, the same thing as 1 all over root 2 equal to 2v2 sine theta. The same way we did, we rationalize this, and this becomes v over 2, 1 over root 2 times root 2 all over root 2 equal to 2v2 sine theta. So we have v all over 2, this is root 2 Then 2 root 2 times root 2 is 2 times this is 4. That is 4. This times this is 2 times this. So we have 4 or divide by 4 equal to 2v2 sine theta. And this will be our equation 2. So we want to solve equation 1 and 2. Solving equations 1 and 2, that is 1 is v minus v into 4 minus root 2 all over 4 equal to 2v2 cos theta. This is our 1 and our 2 is this. So if you now divide equation 2 by 1, if we divide equation 2 by 1, we now have 2v2 sine theta divided by 2v2 cos theta equal to, we now have v root 2 over 4 divided by v into 4 minus root 2 all over 4. Remember, when you divide, this will take care of this. And sine theta over cos theta is tan theta. So you have tan theta now will be equal to v root 2 over 4 times 4 v into 4 minus root 2. Of course, we know this will take care of this. Sorry. 4 will take care of 4. And v will take care of v. And we are left with tan theta equal to root 2 all over 4 minus root 2. So using a calculator, we can find the value of root 2 tan theta is equal to, value of root 2 is 1.4142 divided by, we now have 4 minus 1.4142. What's in that? So by the time you do the subtraction here, we have 2.58 and theta is equal to 1.4142 divided by 2. What we are doing was subtracting this from this. 4 minus 1.4142. So we have 2.5858. So if you now divide the two, we have that theta is equal to 0. By dividing this figure, 1.4142 by 2.5858. That will give us 0.5469. So theta now will be equal to tan inverse of 0.5469. So by the time you use your calculator, we'll have our theta to be equal to 29 degrees.